In this video, we will learn about structure. Structure can be defined as a collection of data members that are related data members under one name. And those data members may be of similar type, may be of dissimilar type. So usually it is defined as collection of dissimilar data items under one name. That is grouping the data items. Structure is used for defining user-defined data types. Apart from the primitive data types, what we have in any programming language like C language, we have primitive data types like integer, float, double, so on. Using these primitives, we can define our own data type depending on our requirement. So this structure I am using more frequently in my course. So in this video, we will learn how to define a structure and what does it mean by the size of a structure, like how much memory it consumes, then declaring a structure, then accessing the members of a structure. Let us learn about these things one by one. Let us take an example of a rectangle. A rectangular figure will have properties like length and breadth. So it will have length and breadth. These two things together defines a rectangle. So if in your programs you need something like a rectangle, then you can define a structure for it, because rectangle is not defined by just one value, it is defined by a set of values. So that is length and breadth. So we can group them together under one name and define it as a structure. For example, rectangle. So here I define struct rectangle. Now inside this, I will take integer type length and integer type breadth. Now this is having two members that are length and breadth. I am taking them as integer type. If you want, you can take them as float or double, any type depending on your requirement. I am assuming that these are simple values which are integral type, no decimals are there. So structure rectangle is defined by its length and breadth. These two members together are defining a rectangle. So this is a definition of a structure. I have taken an example of rectangle. I'll be showing you more examples upon structures later on. So let us learn further about this one. Now, how much memory this rectangle will be consuming? See, it is having two members. This length integer type, if I assume integer takes 2 bytes, or it may take 4 bytes, but I am assuming it has 2 bytes. Now breadth also takes 2 bytes. Total, it is 4 bytes of memory. So this structure is taking 4 bytes of memory. Right now it's not consuming any memory because it is just a definition. So if I create a variable of this type, then it will be occupying that much memory. Now we have seen how to define, we have learned how to know its size. The size of a structure is the total amount of memory consumed by all its members. Now next, let us learn how to declare a variable of that type structure. So inside main function, I will write on a main function. Now inside a main function, if I declare a variable, so the method of declaration is write struct as a keyword, then give the name rectangle, then I'll give the name as R, rectangle R. This is a declaration. Now this R will occupy memory space, right? This will be created in the memory. So how it looks like R is of type rectangle, so it's having two members, that is length and breadth. So R will occupy total 4 bytes, and first 2 bytes are for length and next 2 bytes are for breadth. So yes, that is occupying memory. This is the method of declaration. Now, if suppose I want to initialize it, then I can declare and simultaneously I can initialize it. So let us say struct, I will rewrite the same thing. I will say rectangle, right? I'll use the same name, R, with values, I can say 10, 5. So length is 10 and breadth is 5. So 10 and 5 will be filled in this one. So this is how we can declare as well as initialize. This is just a declaration, right? And this is declaration plus initialization together. This is declaration plus initialization. Then inside the main memory, if you want to see where this R is created, so it is created inside the stack for the main function, is inside the stack frame of main function. So R will be having length and breadth. This is length and breadth, and this is 10 and 5. So I'm showing them side by side. So we have learned definition, declaration, and initialization. Now, how to access the members of this structure? Suppose I want to access this length. I want to modify it to 15. So for accessing the members of a structure, we should use structure variable name and a dot length. So this is length, assign 15. So this value will be changed to 15, right? So it is changed to 15 in the memory. So this is how we can access. So what is the operator used for accessing a member? Dot operator is used for accessing a member. Then r dot breadth, I can modify it. R dot breadth, assign 10. So this is modified to 10. So if you want to read or write the members of a structure, dot operator is used. Here I will calculate the area of a rectangle and show you. So directly I will print the result. Printf area of a rectangle is area of rectangle is percentile d. So here I will write the formula. So what is the formula for area? Length into breadth. So how to access that length and breadth? I have to use dot operator. So say r dot length multiplied by r dot breadth. So this is how I can access the members. So length and breadth will be multiplied, that is 15 into 10, and I'll get the result as 150. So that's it about the structure. This is sufficient, and more about the structure I will discuss when I talk about pointers and functions. So this was just the introduction to structure. So let us continue with the other topics in the next videos. So that's it. We have learned about how to define, how to declare, and how to access the members, and where it is created in the memory when you are directly creating or declaring it inside the main function, right? Declaration or initialization, where it is done. So it's inside the stack frame of that particular function. Now I will give you few more examples of structure. So I will write down few more structures to give you the idea how or where we can use structures. Let us look at the example. So the first example, I will write a complex number. Complex number. So complex number in mathematics is defined in terms of a plus ib, where I is a imaginary number. So two real numbers are a and b. So where I is defined as root of -1. So if you are familiar with the complex number, then you can understand this. Otherwise, just you can Google it and find out what a complex number is. So complex number is defined in terms of a plus ib. So we need two members, a and b. So complex number is defined in terms of two elements. So that you can group them and define a structure. So here we can define it as a structure, struct, complex, and inside that we can have two members. One is a, or I can call it as real part, and second one is imaginary. I can name it as b, or also I can call it as imaginary, that is img. This is our definition. Now you can define a complex number like this, and you can create the variables of complex numbers, and you can use them in your program if you need this complex number. Now second example, I'll take an example of a student. Suppose your program is dealing with students' information. So for a student, we can define a structure. A structure for a student may contain the details of a student. So let us say I want to store the roll number of a student, and suppose a roll number is integer type. Next, I want to store the name of a student. So name of a student is a string. So I will have an array of a type character for name. Let us reserve 25 spaces. So it can store a name up to 25 characters. Next thing, I want to store department of a student. So department is also a name. So it's a character type. Let us give the name of size 10. Like computer science or mechanical engineering or anything, you can give a short form of a department name. Next, I want to store the address of a student. So address, I can take it as of some size, let us say 50 bytes, right? So I think it is sufficient. If you want to add, you can add many things like the phone number of a student, email address of a student, date of birth of a student, a lot of things you can add. So that all together forms a single student structure. And when you declare a variable, you get all these things together. And you can access each of them individually using dot operator. So this is another idea of a structure. Now, if I calculate the amount of memory it's taking, like if I say this is 2 bytes and 2 bytes, so this is taking total 4 bytes. And if I take this one, this is integer is taking 2 bytes. So this is character type, 25 characters take 25 bytes because character takes just 1 byte. and this is 10 bytes, and this is 50 byte. So this is 60, 75, 77. So this is taking 77 bytes. So this is another example. This is just for a student. You can define it for an employee. So you can have